What's going on YouTube? It's the Middle School Math Man. This video is on parent functions and how transforming the slope or the y-intercept, kind of how that transforms my parent function line. So, how does a certain line compare to this parent function? The parent function, or I've also seen it called basic function, that line is just going to be y equals x. So if you think about y equals x, I don't give you tons of information in that, but it actually is in slope-intercept form. Y equals x, so if we were to graph that, what is the slope of the parent function? So there is an invisible like 1 in front of that x, that is just y equals 1x, so my slope is 1. And if I don't give you a y-intercept, we need to know that the y-intercept is going to be 0. It's going to go through the origin. So this parent function is very important. This is how we're going to compare the rest of the equations or lines. We're going to compare these all to that parent function. So if I were to just draw a rough graph, your y-intercept is at 0. And then you're just going up 1 over 1. So obviously if I had a coordinate plane here, or if I had, these lines labeled, it would look something like that. Going through the origin, and it has a slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1. So if we're looking down to number 3, so the directions say, compare the following equations with the parent function. Specifically describe how the steepness changes and if the line moves up or down. So the steepness, so if you think about, the two parts of a slope-intercept equation, we have the slope and we have the y-intercept. So the steepness is going to depend on the slope. For example, a slope or a line with a slope of, 6, let's say y equals 6x, that line is going to be much steeper than our parent function, because if you think about it, if we have a slope of 6, when we're graphing points, we're going to go up 6 points and then over just 1. So we're going to have a very steep line. So the slope is what affects the steepness. And then if the line is shifting or moving up or down, the effect or the change in the y-intercept is what is going to shift my line up or down. So if we look at number 3, we have a slope of -2 and a y-intercept of 3. So if we're comparing that to the parent function, so specifically they want to know, how does the steepness change and is the line shifting up or down? Well, kind of what I'm looking for here is, as a slope of -2 is going to be steeper than a slope of 1. If you think about a slope of -2, we're going to be, rising 2 and running 1. So we're going up 2 and over 1 instead of up 1 and over 1. So -2 is going to have a steeper slope. And then a y-intercept of 3. So I'm going to erase this so I have a little bit of room. A y-intercept of +3. If you think about this line, y equals -2x plus 3, compared to my parent function has a y-intercept of 0. So if I'm looking at a line that has a y-intercept of 3, so y equals -2x plus 3 is going to shift up 3 units compared to my parent function. I'll just call that PF. So that line is going to be, up, or it's going to be higher up on the graph than the parent function because the y-intercept of 3 is shifting that line 3 units up. So number 4, y equals x minus 7. So when we compare that to the parent function, so the steepness is actually going to be the exact same because they are the same slope. They're both 1. Then the y-intercept of negative 7, that's going to tell us that that line is just going to be shifted downwards 7 units. So y equals x and y equals x minus 7 are going to be very similar looking lines. It's just the first one, y equals x minus 7, is going to be shifted down 7 units because the y-intercept is changing it. So at this point, why don't you try to pause the video and try these next 4 on your own. I want to know how each of those equations, how do they compare to that parent function of y equals x? So I want to know if the slope is more steep or less steep, and if the line is shifted up or down. So for number 5, a slope of 5 is going to make my line more steep than the parent function, because a slope of 5, we're going to be going up 5 and over 1 instead of just up 1 and over 1. And it's actually not going to shift up or down at all because there is no y-intercept, so it's 0. So same as the parent function. Number 6, again, we're comparing to the parent function. So a slope of 1/2. So a slope of 1/2, we are going to be rising 1 and running 2. So we're going up 1 and over 2. So that line is actually going to end up being less steep than my parent function. Because instead of going up 1 over 1 each time, I'm going up 1 and over 2. So that line is actually going to be less steep. And a y-intercept of 6, that line is going to be shifted, compared to the parent function, it's going to be shifted up 6 units. Moving on to number 7, a slope of 6 is going to be more steep than the parent function. 6 is going to be a much more steeper slope than 1. In a y-intercept of negative 21, it's going to be shifted down 21 units. And then number 8, so a y-intercept of 2/5, so up 2 over 5 is going to be less steep, again, than the parent function. And a y-intercept of negative 1, it's going to be, that line compared to the parent function is going to be shifted down 1 unit. So again, look at the slope, look at the y-intercept, and talk about how the slope affects the steepness and how does the y-intercept either shift the line upward or downward. So the next part of it, I'm going to give you a graph. So it says graph the parent function in blue. So I'm going to try my best to graph that parent function. So it's going through the origin and it has a slope of 1, so up 1 over 1 each time. Then graph each of the other equations in red, and we're going to compare. So y equals 1/2 x minus 3. Again, just a little review. We have a slope, a y-intercept of negative 3. So that's going to be my first point. And then from there, I'm just going to use my rise over run to get other points. So up 1 over 2. We could even do more points. You could go down 1 to the left 2. So there I have a pretty good line there. So now I want you to compare how the red line that you guys graphed, the one from question number 9, how does that compare to the parent function? So you should be able to see that the y-intercept shifts it down 3 units, and a slope of 1 over 2 is going to be less steep than the parent function. Number 10 is actually not in slope-intercept, so we're going to have to do a little bit of work to get it in slope-intercept. So I'm going to start by subtracting 9 from both sides. And then I need to divide both sides by 3. So I have y equals negative 2x minus 3. That is my equation in slope-intercept. So my parent function again in blue. And then in red, we're going to go y-intercept of negative 3, and I'm going to have a slope of negative 2. So I'm going to be rising 2 and running 1. And again, just make sure your line is negative, has a negative slope. So my line is going to look something like that. And again, the y-intercept of negative 3 is going to tell me it's shifted down 3 units. And a slope of negative 2, that line is going to be steeper than a slope of 1 in my parent function. So why don't you go ahead and pause the video and try these next two on your own, and unpause it when you are done. So number 11, let's go ahead and graph it. Well, let's graph our parent function first. Again, you should take a little bit more time than I just did to graph that. Actually do your rise over run. Although what I graphed was actually not bad. So when we graph my other line, y-intercept of 1, and then we're going to go up 3 over 1 with my slope to get other points. So my line is going to look something like that. And as you can tell, the y-intercept of 1 means it's going to be shifted up 1 unit, and then a slope of 3, as you can see, is obviously much more steep than the slope of 1. Number 12, parent function in blue. I guess number 11 was supposed to be in red, but I did it in green. Number 12, we don't have a y-intercept, so it actually has the same y-intercept as the parent function, 0. And let's see, it's negative 2/3 is my slope. So I'm going to rise 2 and run 3. And again, it's negative, so make sure my line has that negative slope. So you can go ahead and graph that line. So obviously it's not shifted up or down at all because it has the same slope, or excuse me, it has the same y-intercept of 0. And this one's a little bit harder to tell, but actually it is going to be less steep than the parent function. So I'm going up 2 and over 3. If it had the same slope, I'd be going up 3 and over 3. But I'm going up 2 and over 3, so it's going to be a little bit less steep. So again, just a quick recap. In this video we talked about the parent function, which is y equals x. And then the slope is what's going to affect the steepness of the line compared to the parent function. The slope is either going to make it less steep or more steep. And then the y-intercept is going to be shifting the line up or down, compared to that parent function.